Well, welcome back to my channel. In today's video, I'm going to show you how to use the distance sensors so you can make machines that are able to track objects or respond to objects around the machine. So let me show you. Okay, to make a machine that is able to respond to an object using the distance sensors, I'm going to have a simple setup here. Okay, so I'm just going to bring up a box. Make sure the box won't move. Alright, now I'm going to add a motor. This motor is going to turn left and right in response to an object that is within the distance sensor. Then bring up two distance sensors. By default, the distance sensor, which is the red pyramid, you can change the shape of that pyramid to a different shape just by going to the properties menu of the distance sensor. And then you go into the tab that says sensor. And there's a button here that says pyramid. It's a drop-down menu that shows different shapes. I'm going to select box. And then I will change this setting that says ignore attached objects, parentheses, not including joints. I'm going to change this setting to the second one that says ignore attached objects, including joints. Selecting that setting will help prevent your machine from detecting itself. So I'm going to set it to that setting. I am also going to checkmark this little box that says ignore static objects. What that setting does, that will prevent the sensors from detecting any static objects. Since we want to track a non-static object, I'm going to check that setting. And when you click OK, then you reselect the pyramid, the actual distance sensor. You see that the field now became a cube. And the cube is partially see-through. You can change the size of this field by selecting the red field and then holding down the Alt key. The Alt key will appear these white spheres. These white spheres indicate the faces of this object. You can change this size just by selecting on one of these spheres and then dragging to stretch the object to that direction. I'm going to make it wide like this. Alright, now we're going to simply copy and paste that same sensor and then just put it on to the other side. So I'll just select on the distance sensor, and while holding down the object and also pressing the C key on the keyboard, that automatically copies the object. I am now going to move this field. One useful thing you can do when you're editing distance sensors is to enable a setting on the screen. Enable this setting here on the bottom right corner that is called sensors. You can select on this button to help reveal all the distance sensors. This helps you edit any distance sensors that are either overlapping or you just want to see all the distance sensors at once. So let me just drag this to about here. After you got done arranging the pieces like how I showed you, you can now attach the distance sensor to the motor so that the motor will respond to the distance sensors. You can go to the wire mode of the game by pressing this button in the menu that says show wires. After clicking that, you can see the wires. Now you see the yellow nodes of the distance sensors. You also see the yellow node of the motor also has this green node. Now you can simply just click on one of the nodes, which is this left one. Click and drag, which will create a yellow wire and connect it to the green node of the motor. Doing this step first, just testing out one distance sensor, will help you determine which direction the motor will spin. So let me press the button that says show wires again to go back to the normal view. Then I'm going to spawn up a box as the object that it will track. I've arranged the distance sensors to have a gap in the center. That gap is an indicator of where the machine is going to be pointing. And now you can start the simulation. Since I've only attached one distance sensor to the motor is going to be continuously spinning one direction since that one sensor is getting continuously triggered by the presence of this box. You can actually see the sensors while the simulation is running by pressing this button here that says sensors. Of course, the machine is continuously spinning. I've done this to figure out which direction will the motor spin, since it is spinning continuously to the left, and since I have attached the left distance sensor and is spinning to the left, that means I know the polarity direction of the motor. I will stop the simulation, and then now, going back to see the wires, I will now then attach the right distance sensor to the motor, and I will change its polarity to red or negative. Now since there's two sensors, the left sensor and the right sensor, the machine will respond to the presence of the object. So when I start the simulation now with both of these sensors attached to the motor, and you notice that the machine isn't moving at the moment, but when I click and drag the box to the left, you see that the machine starts moving to the direction. But you also notice how the machine started to oscillate back and forth more and more until it became unstable. The reason for this is that the motor has zero resistance, and the motor isn't maintaining its position. The way to make this more stable is to change the setting within the motor. If you go to the motor and then go to the properties and go to the motor button tab, then changing this setting from interpreting as force, changing it to velocity. The motor should only move in accordance of its current velocity. If there's no input, then the motor resists or slows itself down position. So after you change the motor setting, then when you start the game, now when I move the box, the machine is actually tracking the position of that object. If you click on the sensors again, you can see where the object is triggering the machine. After you change that setting in the motor properties, you can now start the simulation to see if the machine is able to track the object. I will drag the box, and then you will see that the machine will respond in accordance with what distance sensor it is triggering. As you can see, it is actually tracking. Adding distance sensors to your machines gives your machines the ability to respond to objects, giving your machines more of an automatic behavior that makes it seem like your machines are alive. I'm going to construct something that will track an object within the 3D space that can swivel left and right, but also up and down. Let me quickly build that. I just now got finished making a more complex version of the tracking system that uses distance sensors. I constructed this machine that has two motors, so they can go left and right, and also up and down. So when I start the game, you can see that the object is getting tracked by the machine. I also placed a force beam to act like a laser pointer so that it will point to the object that is tracking. The speed of this machine depends on the settings you put into the motors, as in the force and the velocity. Increase the velocity too high, that will end up making the machine oscillate. It won't be stable. So there was a few parameters you have to fine tune to have the tracking to be very stable and reliable. And also, you'll notice that the range of the distance sensors is currently right now this short. So if I drag the object away from the distance sensors, the machine is no longer able to detect the presence of the object. The object needs to be in the field of the distance sensors for it to detect it. You can actually change the size of the sensors to be very, very large. You can change the size of the distance sensors fields to be as large as you want, able to track an object at a very far distance. Alright, that's the end of this video. I hope you enjoyed it and maybe learned a thing or two about how to play this cool game. Alright, that's the end of this video. See ya.